right, we are back on the real stage, and this will be the last talk, and it will be about DevSecBioLawOps and the current state of information security by René Pfeiffer from DeepSec. Thank you very much.
Thank you. This presentation was held a couple of weeks ago at the University of Applied Sciences in St. Pölten. The reason why I'm trying to, let's say, make fun of these buzzwords you see there, DevSec, DevOps, and all this stuff, is because I'm I'm a consultant in infrastructure for over 20 years now, so I've seen a lot of technologies come and go in the IT world, and in my opinion, IT is driven by trends, by let's say, solutions which might be interesting for some period of time, and there's not much companies out there, or let's say working groups or teams that know or understand what continuity means and how they build up a long time expertise and a base of knowledge which allows them to deal with problems. And this is why I call this DevSecBioLawOps, because people nowadays need to know everything, which isn't possible. So, why I am talking about this, I'm a senior system administrator. I've worked for many companies, many customers. As you know, I'm part of the DeepSec organization team. I started out studying physics. I started to use the internet in 1992. And I'm familiar with techniques of software development, different computing platforms, and the ins and outs of system administration. So, the background. Why am I talking about this? As you know, the internet started out small as a research project, and many things we see now and use now have started out in academic research. This is the actual internet many years ago in the 70s. Very small, no signs of cyber warfare, no geopolitics, just let's see if this thing works. To recap the last 50 years of internet history, if we add IT security to the academic research of the internet, you will notice that people realized very early that things need to be protected and segregated from other parts of the network, so people used passwords. We still use passwords, but people started to use passwords in the 60s. The first malicious software isn't new. It was very old, especially if you consider the internet was a testing platform and people tried to test if malicious software could attack systems and if you could defend against this. And there was let's say, a test case where a computer worm would infect computer systems, and another piece of software would find infected systems and clean up these systems. This was a research concept, and nowadays it's part of cybercrime and common. Getting access to networks or getting into a network was a problem in the 80s. We have now much more ways to get online, to connect to the internet, but back then you needed to use, let's say, an analog modem to dial a number, to connect to a system, maybe the internet, and so people tried playing cat and mouse game, how to connect to a net, how to use the resources, and how to abuse them, which also led to the so-called Morris worm, which was not a research project, but also a piece of malicious software which infected computer systems. And in the 80s, people realized that in case something goes wrong, in case something happens, you need a team of experts who deal with the incident. And so the first computer emergency response teams were founded and started to operate. With the spread of the network, people tried to protect networks to some more extent by using firewalls, filters, and other, let's say, doors, controls, gateways. So in the 90s, firewalls had their peak in terms of technology. And as you know, governments are always a bit late to catch up. If something emerges, a new technology spreads in society, the first people to use these technologies are probably cybercrime or criminals, then maybe companies. And in the 2000s, governments tried to address these problems, crime done by using digitalized systems, by applying, let's say, changing laws to deal with that. We've seen in the 2000s and later an acceleration of incidents in forms of data leaks, breaches, infections of infrastructure and stuff like that, which is partly due to the spread. Because if you take into account the users of the internet, in the 60s and 70s and 80s, there were less people using the internet. Now we have more, so naturally we have more problems with that. So it's not an indication of the capabilities of the technology. It's just technology spreads, more people use it, more things happen. And in the 2020s, which is right now, people tried to solve problems by inventing new acronyms. This is not new in IT. If you take a look at computer science, there are a few branches of research and technology where you will find more, let's say, abbreviations and artificial words and descriptions than in IT. And DevOps has caught my eye in the past years because some companies try to switch to a new level of developing software and working, which is what I'm going to talk about. So what will happen in the future? I don't know. Probably we will have all of that, because if you take a look back at the history, not much of these problems we had in the past have gone away. They're still there. We still have computer viruses. We still have people abusing networks. We still have incidents. We still have discussions about how to apply the law to all these things that can happen. And so you could gather from this that nothing much has changed. So back to IT security, back to the basics of IT security. IT security is something which covers a lot of different disciplines. It's not only about using a computer or putting the hardware together and running code. It's about telecommunications. You have algorithms coming from mathematics. You have the actual hardware based on the principles of physics and chemistry. You have engineering, trying to put everything together, to increase the performance, to do mass production. Then you have psychology. People are using the computers, not machines. You have human interaction. You have the problem that how to apply the law to different corner cases or actual incidents. Then you have the whole problem about linguistics, which the previous talk illustrated. How do you analyze how people communicate? You have to know about the language. You have to know about the culture. You have to take economics into account. Why do people do special stuff? Why do we have smartphones? Why can we use them without paying a monthly fee for actually having a smartphone? It's all tied together. And then you have all the boring stuff, such as logistics. How do you get the resources to be networked, to be online, to use your hardware? And all these disciplines you see there have an influence about what happens to a system. If you take some of the incidents reported in the media, you will probably find always more than one, maybe even more than 3 or 4 aspects where you can say, okay, these fields have an influence in this incident because someone made an error in engineering, a hardware broke down, some algorithm had a bug or whatever. So you're playing in this wide area of different disciplines, and you have to master all of them in theory to learn about and to know about information security. And this brings me to a problem, because when students ask me how to start in information security, there isn't really a good answer, because basically you can start anywhere, but the problem is what to do first. And people always wonder what's the best way to get into this, but there are more problems. Even if you manage to work in information security, if you're tasked with securing a system or writing secure software, how do you stay on top of the technology? Because if you take a look at the possible programming languages, modules, ways to solve problems, it's increasing every day, and you have to keep on. You have to keep your knowledge and increase your practice. So how do you stay up to date? And well, you can start anywhere, which isn't very helpful, because if you don't know where to start and someone tells you start anywhere, you're not much wiser than before. Yeah? But we come back to that later. The next problem I see in companies is if they are looking for IT security experts, they would like someone who has worked for decades in a specific field or more than one field, should not be older than 25, and should be an expert in 3, 4, 5 disciplines. Yeah? This isn't possible. You can't get people with skills without having experience. This is not possible. Plus, given the amount of content you have to teach people, and given the resources university get or don't get, it's hard to fine-tune the education programs and the curriculum to the actual demand that someone has in an organization, such as a company or wherever. Yeah? So it's very difficult. How do you stay up to date? Computers can read more or faster than the human brain. So if you want to understand something, you need time, which you don't have. Because even in a product, you have deadlines. If someone enters a team, needs to learn the programming languages, needs to get to know the technology, you never have time for this. Yeah? Plus, all the trends and buzzwords flying around in IT security only contribute to the distraction, because you maybe have realized that some of the newest and most modern concepts are really something which has been done for years and decades. It's just a new platform, a new wrapping, but the content is the same. And there's another thing. DevOps, which I referred to in the title, was meant to destroy the silo mentality existing between persons, teams, and companies. Because if information security and if developing new technology is a combined effort of different disciplines, then the people must work together, and the silos of experts you encounter in most organizations hinder the progress, because you find them everywhere. The problem is, information technology, not only information security, requires specialization. You need to have a specialization at some point to do some actual work. This means you need background knowledge. This means you need a collection of tools you use, and you need experience with that. And this automatically leads to silos, because if you're in one field and someone is in another field and you want to discuss something, you first have to know the language, and you have to overcome these barriers. That's not new. That has been existing even without the internet, so that's really something people do. And if you take a look at who was the last person who probably knew everything at their time, I was taught in university that this was probably Mr. Leibniz, who was the last universal expert, being an expert in all fields at that time. Yeah? And this time is long gone, because you cannot know everything in every discipline. This is impossible. And this effect of creating silos and creating specialists has been accelerated by the pace technology invents new stuff and invents new processes and new tools and new products. As you know, we have Moore's law, which still holds, Plus, you have millions of specifications, hardware platforms, devices, computer chips, libraries, and whatever. And you may have noticed that some decades ago, the versioning of software was very traditional and conservative. You had a specific version of a software, then you had an update. Most products have switched to rolling updates, which means you get updates every day, every second, every hour, whatever. So everything you use, the code, changes constantly, which is, let's say, a problem. If you introduce new bugs, you probably introduce new security weaknesses. But for some products, that's how they are, because you cannot freeze a software at a specific point. You could, but this means maybe a weakness stays the same and you run into troubles. But that's how you work. And most teams have taken this for granted. You don't know which software version you're actually using. You just get the newest library and things will hopefully work or not. So once we have silos which contain barriers that makes working together difficult, we also have personalities and mindsets. Because a silo can be good or bad depending on if people can still communicate, and it depends on how people approach these barriers. And the first thing you have to keep in mind is the fewest problems I have when working as an external consultant in projects is when people listen to you. If they respect your opinion, if they respect your experience, and let's say you're on the same level and no one discredits another person, then you have a good chance that you can work together as a team. But this also requires that you have a common language and common vocabulary and something that is shared among all of the team members. This can be difficult if your team consists of people of different disciplines, because we all know some research disciplines or some specialists have their own language, have their own culture, and learning this can be a challenge. Plus, in IT, you often have wildly different ways to do things. You probably can use the use of tool chains or programming languages as a let's say, as a marker for the personality of a person, which sometimes allows you or doesn't allow you to communicate with each other. And the problem is, in IT, there are some, let's say, mindsets that say, okay, what I know is most important for the project because I work at the core of the product. I'm doing the database, the infrastructure, so my code is the most important part of the project. Or if you have different teams, then you get the blame game. People shift the blame, say, okay, my code would work if you wouldn't be so crappy, if your code would work better, and things like that. That's something to look out for in teams, and something that should be addressed before it gets out of hand. And I've worked in teams where you really couldn't do much besides the accepted opinion of some key silo team leaders, because they dictated which code to use and which products to use. This can be a problem. But this is something you should keep keep remembering when you address the dynamics of teams. And I give you an example, because I'm doing system administration since the end of the 90s. And basically, running servers or running code has been the same ever since. There are other tools now, other platforms, other companies, but you still need code where things can be executed. And there's a term called serverless computing, which is in the cloud, let's say new technology in the cloud. It's used for let's say, accelerating the development of code, because the idea is don't bother the software developers with infrastructure. Let them run their code anywhere, so they can test their code without interfacing with system administrators, without paying extra, waiting for servers. But the problem is, serverless computing is a marketing term, because guess what? Serverless computing has servers, because your code has to run somewhere. And some IT security experts jokingly say, Serverless computing means your code runs on a refrigerator now or on a smartphone. Could be, but the basic message of serverless computing is I don't care what the platform does, who owns it, how much it costs, I just want my code to run. That's it. And basically, another translation is I don't want to worry about the details, let someone else do it. So serverless computing could be helpful for your team, or could be shifting the blame to someone else, preferably someone outside your team so that you are not to blame for anything. This is a valid approach for certain scenarios, because if your code doesn't care or is, let's say, runs on many platforms, that's a valid option, because you don't want to test your code on a platform that ties you to a specific piece of hardware, a specific situation. And maybe you want to make your code as compatible as possible for most platforms, then it's a valid approach. But if you use this technology for shifting the blame to someone else, or outsourcing the blame, or let's say the reason why something doesn't work, then it might not be a good way to do this. If you remember the silo mindsets, this could also be used as an excuse for maintaining a strong silo mindset and not letting someone else into your team. Because serverless could mean I don't want anyone doing administrative stuff, I just want to run my code and that's it. Some people do this because they don't want to afford a system administrator, or don't want to enlarge the team, or just want to try something. But the problem is, this could mean that you are tying yourself to a specific vendor and you're not as flexible as you want yourself to be. And the other thing is, most people, especially software developers, which I educate about secure coding, don't think about security in the way IT security experts do. They just want the code to run, and you know the joke, the S in computing is for security, which might be true for some teams and some code. So, the first thing what you have to do when you're doing IT security consulting, when you're working in a team or when you're a project leader, you have to break down these barriers so that they can't destroy, let's say, the communication, and that they are not responsible for introducing specific blockers that people cannot navigate. And the thing is, it's not that easy. I used this slide before the Western forces pulled out of Afghanistan, and this diagram was published, I think, in the New York Times or in an American newspaper, and some journalists discovered it, and they meant to portray the complex situation in Afghanistan. And some people used this as a joke and said, look at this diagram, you can never do something in this country because it won't work. But if you look closely at this diagram, if you use the big version, it's actually not bad, and actually it helps you dealing with a complex situation, because you cannot make everything as simple as you want it to be. Some situations are complex, and you have to deal with that. And sometimes even this diagram or your analysis is incomplete, and you still have to deal with that. So it's something to remind you about. If you're dealing with something, make, let's say, an analysis, determine what influences what, and most of all, look where you are in this diagram. Where's your position? Where's your code? Where's your software? Where's your company? Where's your team? Yeah? Make sure you know where your position is and what other entities or situations can influence you or affect you. So, to get out of this complexity, there are some steps based on, let's say, my experience, so it's a bit biased, but first thing is adding dev to ops, or combining different roles and saying, okay, you are now a team, you have no problems, you have no silos, you're the same, doesn't work. Your team will always have to cover a specific spectrum of knowledge, which might be fulfilled with a few experts or not. It depends on what you're doing. But you will always have a team which has to cover a spectrum of knowledge, no matter how you call it. It's the first thing to realize. And this means, regardless of how you call yourself, if you're a senior consultant, a DevOps, DevSecOps, or whatever kind of person, first thing you have to make sure that everyone in the team can communicate with everyone else, especially with the team leaders and in other teams. That's the first thing you have to do. Establish a common language, find out which specialists can talk to each other and which can't, and make a dictionary, do something, let them communicate. And make sure that everyone can talk to everyone else without someone saying, my work is more important than yours. If the software development team has no power or no internet, then the code can't be that important, because power or internet or network connectivity rules everything. So basically, they have to know that they are not the center of the world and should be okay with that. And the next thing, which is very important, which is especially important for small groups, keep the overhead of managing your group and your administration as low as possible. If someone wants to use a new tool, someone wants to try something, let them do it. Do it in a sandbox, do it in a secure environment if you want, but don't make people fill out forms or lecture them about what they should do, what they shouldn't do. This kills creativity. The next thing you have to take care of is make sure that you get a sensible knowledge transfer from either other teams, external consultants, or let's say project partners. Because you cannot download decades of experience. You have to use didactic methods. You have to teach people actually how they can gain knowledge and transfer knowledge. This is not something it just happens overnight. This is really hard work to do that. And allow team members to make mistakes, because some teams have a very, very bad culture when dealing with mistakes, because things go wrong. I told people at the lunch break yesterday, in April I pushed AWS access keys to a Git repository, and guess what? Someone found it and started servers. So these things happen, even to people who should know better, and there should be no reason to be afraid of making mistakes. So, next thing, very important, leave room for criticism, because criticism is the one tool to improve. Some people think there is one method to do this. I don't think so. Use what works best for your team, because your team is a selection of specific personalities, skills, and mindsets, and there is no one solution for this. Because this one method that solves all your problems doesn't exist. And the personalities in your team dictate how your team operates, not the other way around. And also, always have a look at reports if you have an incident, if something goes wrong, if you have a Q&A, quality assurance section or software testing. Take a look at the results and make an analysis and distribute it among your team so everyone knows what happened. And there's one thing which is, given the news we read these days, which might be impossible, because most of the things you do in technology is fact-based. You have evidence, something has happened or hasn't happened. You have an audit trail, you have a log, you have a report, you have debug code creating information, and all of information security leans on this evidence. Yeah? There's no such thing as, I think this might happen, I think this is okay. You can check for it, you can test it, and if you can't, then think of a way to test it. Which is a problem for some situations, because I spend a lot of time talking about metrics and using metrics or finding sensible metrics. Not everything that can be portrayed as a number is a good metric. You have to check if something that you can measure says really something, because you can create a lot of data in IT security or information technology, but not all data you create or you can copy is really a good metric. And you need to create processes for really finding things out. Maybe you need to compile a team that is tasked with checking metrics and checking things you measure. Yeah? And especially in these days when people can't read numbers and can't see that something has an exponential distribution, mathematics is a hard subject, but you will need it, and especially if you're in computer science or even worse, data science, you have to deal with mathematics, and this is part of your reality. Especially if I see some visualizations or reports that portray something which carries no meaning at all, and people think they found something out. This is really, really, really a problem. And for this process of fact-finding, what you can do, take a look at all your tools and frameworks, understand what you're using, understand which vendors you're using, what their products are, how they work. This is even true for things you take for granted. For example, in my secure coding classes, I have my own section of addressing peculiarities of compilers. Because if you take a compiler language or an interpreter language, people assume the language is defined as a specification and all tools, all compilers and interpreters work in the same way, which isn't true. Yeah? So make sure that you understand what you're using and eliminate every assumption something is based on, because sometimes if the assumption is wrong, your whole code collapses. So that's nice, but this won't work, because this is another image I took from the internet, of course, but this is the process describing how the US Department of Defense maintains the logistic of acquiring, using, maintaining, and let's say phasing out technology. Some things really have a lot of dependencies and can't just be switched on and switched off or bought and sold. Yeah? And the next thing, which is even more depressing, so to speak, this is a selection of tools which are used in modern cloud platforms. You have a lot of vendors in there, you have all the platforms, the cluster services, the software that manages things, the APIs, whatever. Basically, if you say DevOps and you say you want a good DevOps engineer, what you're actually saying is, I want someone who knows all of these products by heart. That doesn't work. This doesn't exist. This person doesn't exist. So, what to do about this? Because I don't want to end in a depressing slide. The thing is, you have to start somewhere. If you're intimidated by the complexity of technology and the size of code bases and whatever, don't be intimidated. You have to start somewhere. If you want to learn about IT security, you can start anywhere, but start with somewhere. Don't get intimidated by complexity, and don't get too, let's say, arrogant, because never assume that your software can deal with any situation it encounters. There might be some things you haven't considered, and especially in IT security, attackers will find this situation and use it against you. And the most important thing, this is why I used some of the buzzwords going around in human resources departments, don't get distracted by trends, because even we have cloud platforms. In these cloud platforms, there are the same processors you have on your laptop, just bigger, but that's the only difference. Yeah? So meaning we basically use the same technology, albeit refined, than 40 years ago. Code still runs on processors. So what? So don't get distracted by trends, and don't assume that someone else will solve your problems for you. You have to do this yourself. And most importantly, if your team consists of more than one person, which it usually does, you always have to take into account the personalities on your team. You cannot change the personality of a person. You can combine persons working together, but you cannot change a person, and you cannot make personality traits go away. This is not possible, and you have to accept that fact. So, maybe I'm wrong. If so, I would like you to tell me, but maybe you recognize some of the situations I talked about, And I would be happy if you, let's say, ask me some questions or tell me that I'm wrong or tell me that you've seen similar things. Thanks.
Thank you very much. Are there any questions? Or is there someone who wants to answer these questions?
Are there DevOps specialists present? You look like a DevOps person.
Well, let's ask him, right?
What is the question? Do you like DevOps? If yes, why? If yes, if not, why not?
I don't like hiding complexities in new terms. That's what my point is.
I like that. We should promote this more because there's so much complexity out there in the world and no one understands it.
I'm trying, and the thing is people, because containers and platforms have their, let's say, have their advantages, but I'm a long-time C and C++ developer. I started using C and C++ in the 80s. So people started with containers, and I was just wondering, what's so new about compiling static code? We did that in the 80s. So why is this new? And that's what I meant. Question what's going on. I mean, containers have their, let's say, advantages, but know what you're doing. That's my message.
Sadly, people don't know what they do most of the time.
Well, keeps our job safe.
Thanks.
Thank you. More questions or answers in this case? Okay. We have a question.
Yeah, when you take this kind of attitude, how often do people earlier in their career just say that you're a grouchy old fart who doesn't like anything new?
Happens a lot. But the first thing what I try to do, especially since I'm almost all of the time, I'm an external consultant, I don't know the people. What I try to do first is I try to get to know them. Because I don't know everything. Just because I have my bias of tools, my special tools, doesn't mean someone else has not a better idea. But the first thing I do when doing a project, I always try to get to know the personalities of the people and try to understand how do they mean that. Do they really mean this because they don't know anything else, or because they can't take criticism, or it's just their way of doing things? I have to find out before I judge them.
Okay, more questions? All right, then thank you very much.
Thank you.